Hi, welcome to my video on the unit circle. This is the unit called the unit circle, but this is the video showing you the rotations on a unit circle. Unit circle. Unit means one. Unit circle has a radius of 1. Radius can be 1 foot, 1 inch, 1 mile, 1 millimeter, 1 centimeter, 1 meter, 1 kilometer. Here I have drawn a circle, and I said the radius is 1 centimeter. So there's 1 centimeter from there to there. So this point right here is 1, 0. And there's another circle drawn, and I said the radius of this one is 1 inch. So that's 1 inch from there to there. Again, this point is 1, 0. And as in all of them, then this point is 0, 1. Mark 0, 1. This point is negative 1, 0. This point is 0, negative 1. And also over here, this is 1, 0. This point right here is 0, 1. This point right here is negative 1, 0. And this point is 0, negative 1. Again, notice the x here is 1, y is 0. On this side, x is negative 1, y is 0. When you go up, the x is 0, y is 1. When you go down from the origin, x is 0, y is negative 1. And let's just review now about sine and cos. A unit circle has a radius of 1 with a center of 0, 0. So there's the radius of 1 right there. So there's the center 0, 0. So this point is 1, 0. This point is 0, 1. And this point right here is x is negative 1, y is 0. And this point, x is 0, y is negative 1. So let's plot the point x, y on, let's say this point P is x, y is a point on the unit circle. So let's plot P right here. And this point has the coordinates of x, y. If you drop a perpendicular to the x-axis, the terminal arm goes out through that point. So the rotation for this angle is theta, and this rotation is equal to the central angle, which is the same measure. So this is a right triangle. So this is the x, this is the y, and this is 1. The radius of the circle, the hypotenuse of the triangle is 1. So cos of theta is the adjacent, which is x over hypotenuse 1. So that's the same as x over r, which is x over 1, which is x. And the sine of theta, opposite over hypotenuse, is y over the r, which is y over 1, which is y. So on this unit circle, whose radius is 1, cos of the rotation is x, the sine of the rotation is the y. And that's just a review of the previous videos that we did. So now let's take the point 3, 4 lying on the terminal arm of theta. So the point 3, 4. So x is 3 and y is 4. So let's take this point right here to be point P, which is x is 3, y is 4. We drop a perpendicular to the x-axis, and the rotation for theta starts at the point. Now notice this point here, the radius is 5, so this point is 5, 0. So when we rotate theta up here, that's the rotation of theta. We drop a terminal arm going out to that point. So this angle, rotation theta, is right here. And so x is 3 in this triangle, y is 4 in this triangle, and we have to find out what the hypotenuse or the radius of the circle is. So r squared equals x squared plus y squared. So r squared, x is 3, y is 4, r squared is 9 plus 16, r squared is 25. The square root of r squared is plus minus the square root of 25. Square root of r squared is r, plus minus 5. But the radius of a circle is always positive. So this radius, or the hypotenuse of the right triangle, is 5. And according to theta here, cos is the adjacent over the hypotenuse, or is the x over the r, so it's a 3 over 5. And the sine of theta is the sine is the opposite over the hypotenuse, which is the y over the r. And that's 4 over 5. But if we look at it, this is the hypotenuse of this big circle is, or the radius of this big circle is the hypotenuse of this triangle, 5. But if you take this circle here, which is the same center, 0, 0, and you do this rotation, this is a 1. So that's 1, 2, 3, 4, 5. So that's a 1. And we drop a perpendicular to the x-axis, then the hypotenuse of this triangle is a 1. The radius of this circle is a 1. So this is the point 1, 0. And the triangles are similar. So if you draw the small triangle and you draw the large one, I'm not drawing it into like that. This angle theta is the same angle theta here. This angle right here. And you have a right angle in these triangles. The triangles are similar. So this is a 4, 5, and 3, and this is a 1. Then this ratio here, which is the x, works out to be 3 over 5. And the y is 4 over 5, obeying the same ratios. So 4 over 5, this is the same as 4/5 to 1, so you get the same ratio. And notice, again, on this big circle, the cos is the x over the r. Sine is the y over the r. But on the unit circle whose radius is 1, this is 4 over 5, and this is 3 over 5. So on the unit circle, the cos of theta is the x, which is 3/5. And the sine of theta on the unit circle is the y, 4 over 5. So if it's not a radius of 1, then you have to do x over r and y over r. But if you have a radius of 1, then the cos is the x, the sine is the y. Just explaining the other videos, summing them all up. Okay, what about if we put them all on? We did the one. I have triangles here. So right now, let's say that we have a unit circle. And a unit circle has a radius of 1. So this circle, whose center is 0, 0. If this is a radius of 1, then this point is 1, 0. This point right here is 0, 1. This point is -1, 0. This point is 0, -1. So this radius is 1 from here to here. Again, the coordinates of this point is 1, 0. So we're going to rotate. And if we do a rotation of 30 degrees from here to here, and we draw a terminal arm out to that point, and we drop a perpendicular to the x-axis, this rotation of 30 degrees here at this point makes this 30 degrees reference angle. So this makes it a 90, and that's a 30, and that's a 60. Opposite to 30, let's go back to this triangle. What about if we have a 30, 60? I had the triangle drawn here. if we have a 30-60 right triangle with a hypotenuse of 1, then opposite 30 is a half. Opposite 60 is root 3 over 2. So since this triangle has a hypotenuse of 1, which is the radius of the circle, opposite 30 is 1/2. Opposite to 60 is root 3 over 2. That means the coordinates of this point, x is 1/2 and y is root 3 over 2. If you notice the y, because the angle is 30, the y is long out here and the x is shorter. Now, what about if we do a rotation from here 40 degrees? What about if we do a rotation of 60 or 120, etc., etc.? But before I do that, let's look at this right across here. This is at the same point. If we drop a perpendicular to the x-axis and we draw a terminal arm out to this point, then the reference angle here is 30 and the reference angle here is 30. Right straight across. That means that this is a 60. That means if that's a 30, then this is a half. That's a 60. That's a root 3 over 2. So this x is root 3 over 2. Y is a half, but the x is negative. So it's the same. 30 is a half. X is root 3 over. I said, no, notice what I did. No, that's a 1. So just a little error. I will, put x is root 3 over 2. The y is a half. I just did the reverse here. And I corrected myself here. X is a negative root 3 over 2 because x is negative in quadrant 2 and y is positive. Also, if you go right straight down through like that, right on down, and you keep the perpendicular coming down through here, then this reference angle is also 30. This is a 60. So opposite 60 is a root 3 over 2. Opposite to 30 is a half. But in the third quadrant, that's negative, and that's negative. So x is negative root 3 over 2. Y is a negative half. And if we go with the right over to the fourth quadrant, right on through here, drop the perpendicular down through. I was drawing a line there, but I keep it not through. I have a reference angle of 30. This is a 60. That's root 3 over 2. Opposite to 30 is a half, but it's negative because the y is negative going down. X is positive here. So the coordinates of this point, x is root 3 over 2. Y is negative a half. Okay, that's when we rotate it. That means if we rotate, this is a reference angle of 30 here. The rotation for this one is 150 because 150 plus 30 more gives you 180. Because this is a reference angle of 30, this is 180 from here to here, 30 more, and then this angle here is 210 rotation. So if we start here and rotate it 210 degrees, you get to here. These are the coordinates of the point on this unit circle for a rotation of 210. And if you go over here, you get a 30 reference. That means your rotation is 330 degrees. 330 degrees. Because 330 degrees, right here, all the way around, start here, all the way around, that's 330, plus 30 more makes 360. And what about if we rotated 45 degrees? Well, let's look at this triangle, which is 45, 45. Hypotenuse is 1, then these sides are root 2 over 2, root 2 over 2. So if I rotate to here, and that's a 45-degree rotation, and you draw a terminal arm out through this rotation, there's your 45-degree rotation right to here. That means you drop a perpendicular to the x-axis. Okay. This angle is 45 in here now, because it's all this one. and this angle here is 45. That means this side of the right triangle is root 2 over 2, which is the x, and the y is root 2 over 2. So the coordinates of this point is root 2 over 2, comma, root 2 over 2. The x and the y is the same on the 45 right triangle. That means if you come right straight across to here, you have perpendicular to the x-axis. You have another, right straight over, you have another reference angle here, right here, of 45. So that's a 45. So this side is root 2 over 2, again in this triangle right here. And this angle is 45, that's 45. So these sides are root 2 over 2, root 2 over 2, but this is positive and this is negative. So these coordinates, x is negative root 2 over 2, and y is a positive root 2 over 2. The triangles are all 45s. The triangles are congruent, so the coordinates are the same numbers, except the x is negative on this side, the y is positive. And if you come on down, right straight down with your perpendicular to this point, and you draw your terminal arm, again, your reference angle is 45 in this triangle. This angle is a 45. So this side from here to here is negative root 2 over 2. This one is root 2 over 2 negative. So the coordinates of this point are negative root 2 over 2 and a negative root 2 over 2. And if you come right straight across here, then this perpendicular comes on down, and you got your terminal arm coming out through, and again you got a 45 reference angle, 45 angle. So this side right here is the same length in both of these triangles, this triangle and this triangle, root 2 over 2. So this side is root 2 over 2, but it's negative. So the coordinates of this point, x is positive root 2 over 2, y is the negative root 2 over 2. And if this is a 45, and this reference angle here is 45, that means this rotation is 135 degrees. Because 135 and a 45 is 180. So if this is a 45 here, this rotation is 180 plus the 45. So this rotation is 225. And right here we got a 45. So this one right here is 360 minus 45, so it's a 315. So if we rotate from here, right around, right to here, with a 45 degree angle here, reference, that rotation is 315 degrees. Notice they all ends in 5s, same values. And what about if you rotate, instead of going 30, 45, we go to right here. And this rotation right here is 60 degrees. Make 60 here. So if I rotate from here, right up to here, I get 60 degrees. Terminal arm going out through, 60 degree rotation. Then I drop a perpendicular on down through. Gets a little bit, just got to be careful. Gets a little bit confusing. And I know it's going to come on down straight through. So this is a 60. That means this angle here is 60. That means this angle is 30, because you got a 90, you got a 60, and a 30. So opposite 30, you got to be careful. That's a half from here to here. And that's the y value, which is root 3 over 2. So this coordinate, x is a half, and y is root 3 over 2. And if you notice, because you got a 30 degree reference angle, the x value here is further over. So root 3 over 2 is around 0.86. Root 2 over 2 is around 0.7. Notice a half is 0.5. So as you rotate up here, then the x value is going to decrease and the y value is going to increase. So it's a 0.86, 0.7, 0.5. So the x value decreases. Notice the x value is decreasing. So the y value is 1/2, 0.5. So the y is getting higher, up. So that's 0.7 and that's 0.86 or 0.9. So as you rotate from this point clockwise, the x value is decreasing, the y value is increasing. So notice the pattern. And as a result, if you go over to here, right straight across, and you drop a perpendicular on down, and it's going to go right on down through here. There's your right angle, and there's your reference angle. So this rotation is now, the reference angle here, right here, is 60. That means this angle is 30. So that means that this is a root 3 over 2, and the y is root 3 over 2, and the x is negative 1/2. So the coordinates of this point is x is 1/2, y is root 3 over 2, and the x is negative and the y is positive. Again, notice 1/2, 1/2, root 3 over 2, root 3 over 2, but in this quadrant x and y are positive. In this second quadrant x is negative and y is positive. So if you come on down here and you draw this angle, so this angle is 30 because the reference angle right here is 60, and we have a negative 1/2 here. We have root 3 over 2 from here to here, negative. So this point is x is negative 1/2 and y is negative root 3 over 2 because x and y are both negatives in this third quadrant. And only putting them all on the same diagram gets a bit confusing, but the idea is that the next part, one of the next, or not the next video, but a couple of videos from here, I'm going to show you about the graph of the cos and the graph of sine that comes out of this rotation. That's why I'm putting them all here and showing you, and I'll show you a couple more times. So that makes this reference angle 60, that makes this angle 30. So that's a 1/2 right there. This is a root 3 over 2, but it's negative. So the coordinates of this point, x is a 1/2, and y is a negative root 3 over 2. And because this is a 60 reference angle is, when you rotate here 60 degrees, you have a reference angle of 60. This is a 60, so 120, so that's a 120 degree rotation from here to here. But the 60 reference makes it a 180. 60 reference here, so this rotation is 180 plus 60 is 240. And this reference angle here is 60, so this angle here, rotation, I should say the rotation, is 300. Because if you come all the way around, right to here, you have 300 degrees. And so right to here is 300, and 60 more makes 360. So that puts together the unit circle. Notice the radius is 1. So notice these points, 1, 0, 0, 1, negative 1, 0, 1, sorry, 0, negative 1. And notice that when the reference angles are 30, you get the same values in each of the quadrants except plus and minus. And if you have a reference angle in one quadrant and the reference angle in any of the other quadrants, you get the same values except plus and minus, because add sugar to coffee. ASTC. Add sugar to coffee. All trig ratios are positive. The sine is positive. The tan is positive. The cos is positive. And also, if sine is positive, cosecant is positive in that quadrant. If tan is positive, cot is positive. If cos is positive, secant is positive because the reciprocals are positive. So this is where the ratios are positive. That means that the other ones here are negative. The other ratios, the other four are negative. The other four ratios are negative. Everything is positive in quadrant 1 because that's where x and y is positive. Just wanted to review the unit circle. Extremely, extremely important to understand. That's why I took so much time to explain. And if you enjoy my video, click the like button, subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.